going to be showing you guys how to tune a shooter. For this tutorial, you're going to need Vintage Scope 2026 if you don't have it already because you haven't downloaded WPI Lab 2026 or, for example, it hasn't come out yet, then make sure to download it. So we are going to start off by simulating our code, which should be simulated already. We want to enable teleup. We want to turn on our live tuning. We want to go to Advantage Scope, so 2026 Advantage Scope. We want to graph our velocity. Since we're tuning velocity to flywheel, we aren't going to be showing position because it messes with the graph. And then now that we have this, we can turn on the tunable numbers button, which is up here. And then we can go to our tuning. We can go to shooter mech, we can go to shooter motor, and then we can open up closed loop. And so now we can see all of our PID constants, everything that we need to do. So our first thing that we're going to tune is our KS value, or static value. This is the value because our flywheel is not massless, it has weight. It can't instantly move once the motor is given power. So we need to add a KS values to figure out how much power how much voltage, the motor needs in order to start moving. So if we start with 0.1 here, let me just make sure that it's working. Oh, we need to set this to a non-zero value, and then now it works. And then something to make sure of is try to zoom in so that it's within like 1 or 2 seconds, because otherwise it starts getting laggy later on. So we're going to start tuning our KS value. Oh, it's already doing stuff here. It seems like because of how the simulation works that we don't need to tune our KS value, but in real life you do need to tune this KS value and try to make it as close as possible. Let's see. Yeah, it seems like there's no friction, so we don't need to worry about that. Okay, now that we've tuned in real life you would tune KS, but now we need to tune our KV value, which is how much voltage it takes to spin the flywheel at 1 rotation per second. So this velocity on our graph is already in rotations per second, luckily. And so all we need to do is figure out this KV value. So we can start with a very small number. So we can start with like 0.1. And that does not look like it's going anywhere close to where we want it to go. And so what we can do is, actually, sorry about that, we're going to be using KS because KV depends on the velocity. And so since we don't know, we don't have our PID set up yet, we don't want to be tuning with we don't want to be messing with that. So we're going to use KS. So, oh, sorry about that. This was left from something else. You can see right now it says 0.06. That is too small, so we're going to double it. 0.13, too small. And then same thing as we do with the PID. We're just going to keep doubling it until we get to 1. And so now we're at 1, and that looks pretty steady. I might actually decrease it a little bit. That way it's hovering around 1 rather than staying above 1 at all times. And so now that we have our KV value, we can simply copy and paste this into here. And so you can see how now this value is really small, and that's because since KV is now using the velocity, it's using this velocity. But this set point is in degrees per second, while our velocity here, as I said before, is in rotations per second. And so what we need to do is we need to convert the two values. So we're going to go to the 3 dots. In order to do that, we need to click on the 3 dots. We need to edit the units. We're going to do angular velocity, not normal velocity, because normal velocity is moving forwards, moving backwards, moving up, moving down. Angular velocity is spin, spin, spin. And so we're going to go from our graph velocity, which is in rotations per second, to degrees per second. Ignore this extra factor. And so now you can see, hey, look, it's hovering right around what we set it here. And so now if we start editing this value, you can see it's hovering around the correct value. Now, in here, it's not going very fast because degrees per second is a lot slower than rotations per second. It's 360 times because one rotation is 360 degrees. So if we set it to like 360 degrees, you can see it's rotating about every 1 second. But obviously, if you're shooting a ball 30 feet, you don't want your flywheel to be rotating at 1 rotation per second. And so in order to do some of that math, we can bring out the calculator. And so I already have some of the calculations done already, but I'll do it again. Say we want to spin at 1,000 rotations per minute, sorry. RPM is probably the unit you're most familiar with, and so you know how fast 1,000 RPM looks like. For the 2025-26 FTC season decode as well, 1,000 RPM is honestly pretty close to the minimum that you need in order to spin your flywheels. But because if we look in here, our maximum RPM is 1,000 RPM, we might want to lower it a little bit. So I'm going to go 500 just for the purposes of this video. And so to convert from rotations per minute to rotations per second, we need to divide by 60 since it's less time to do as many rotations. So we're going to come out with a smaller number. And now we have this number. We want to multiply this by the degrees. So we're in rotations per second. Now we want degrees per second. And so we're going to multiply by 360. And now we see that we need to set our velocity to 3,000 RPM. So if we go and do that now, you can see that it's getting pretty close to where we want it to go, but it's not getting there exactly. And so now might be a good time where we can add some KS to our shooter. Or actually, it seems like this is the maximum velocity our shooter can handle. So we might want to, for the purposes of demonstration, set it to something lower. So now you can see our shooter is hovering around 2,500. And as you can see, most of the time you just need KV. You don't really, and KS. In real life, you also need KS, but this simulation is not as great. But usually you need KV, but for example, whenever a ball comes through, there's a sudden disturbance, and so the motor needs a little bit of a pick-me-up in order to be like, hey, we got to get back up to speed now, guys. And so that's what KP is for. Usually, your KP value is going to be really, really small, like as in 3 decimal places, as I have here, kind of small. Because, again, KV is supposed to do most of the heavy lifting. KP is just kind of helping it along. And these values are so big that proportionally, this is still, if we do the math, 2,500 times 0.001, that's still setting it at like 2.5 volts. And so that's still a lot of extra on top of the KV. It's a lot of extra voltage that the motor now gets sent to do. Like it gets sent more voltage. And so that way it can help, even though this value might look small, based on our units, it's actually pretty standard. And so just to recap, we first graphed our velocity, and our velocity was in rotations per second. Check with the units on like Phoenix Tuner. I think Phoenix Tuner is also rotations per second. So just check with whatever unit, check your units, because you might see these numbers and they might look very different, but as we saw earlier, if I just reset the units, this looks like a huge disparity, but that's just because we haven't done the multiplication yet. And so that's something to look out for before you start tuning. So the first thing we did is we used KS to find how much it takes to rotate 1 rotation per second. So you can see here 1 rotation per second. And then based on that KS value, we then copy pasted that into KV. Again, this is really important that it's 1 rotation per second because, again, that's the units that our KV is in. It's in volts per units per second. So that's just something to keep in mind. And then once we did that, then we tested out with our velocity. We needed to adjust the units in Advantage Scope using the 3 dots. We used angular velocity because, again, it's not a linear velocity, it's angular because it's rotating. And then we did some testing, we found out some limits, and then we edited our KP a little bit just to make it that much more accurate, especially whenever we have disturbances. And so that's all that there is for shooter or flywheel tuning. For like a turret or something, you might need to consider a different method, since that's more position control. If you want to look at, for example, the arm, that would be a good tutorial, or the elevator. Those might be better tutorials for learning how to tune PID like that. But for at least this flywheel, I hope that this tutorial helped, and I hope to catch you in the next one. Thank you.